Good morning, student. In last period, we learned the chemical nature of a substance with indicator. With the help of indicator, we decide whether a substance is chemically acidic, basic, or neutral. We use for this the indicators are red and blue litmus paper, turmeric paper, and China rose petal indicator in the form of solution. We see that if the solution is an acidic, it turns blue litmus paper into red color, and if the solution is a basic, then it turns red litmus paper into blue color. Similar way, in acidic solution, turmeric paper, color of yellow remains unchanged. It means its yellow color unchanged, remains same with an acid, and yellow color of turmeric paper turns into red color if the solution is base. Similar way, how the color change with the China rose petal indicator with acidic solution and basic solution. Now we have one more indicator. This is phenolphthalein. If you see in my hand, a bottle is an indicator named phenolphthalein. Phenolphthalein is an indicator. It gives pink color in basic solution and colorless in acidic solution. Original color of phenolphthalein indicator is like this. There is a colorless solution of phenolphthalein. Phenolphthalein itself is a colorless solution, and it gives colorless solution in acid if we put a drop of phenolphthalein solution in an acid. Suppose I put some acid. This is hydrochloric acid in a small beaker. I take some hydrochloric acid in a test tube and put a drop of phenolphthalein solution in it. You saw that there is no change in color of hydrochloric acid. So it means that in acidic solution, phenolphthalein indicator remains unchanged, and if I test the basic solution with a phenolphthalein indicator and see what happens. So which type of color is given with basic solution phenolphthalein indicator? You say that the pink color, colorless solution of base, that is sodium hydroxide, is turns in pink color if we put a drop of phenolphthalein solution in it. So phenolphthalein indicator remains colorless in acidic solution and turns colorless to pink color in basic solution. Now we have a reaction named neutralization reaction. Neutralization reaction is a reaction between an acid and base is known as neutralization reaction. So neutralization reaction is reaction between an acid and base. Neutralization is salt and water are produced during the neutralization reaction, and lots of heat is also evolved during this reaction. You see that we have hydrochloric acid, which is acid. I transfer hydrochloric acid into a small beaker. Therefore, we have hydrochloric acid in it. I have sodium hydroxide. I dissolve some pellets of sodium hydroxide into a beaker containing water. Then this is the solution of sodium hydroxide, which is base. So we have hydrochloric acid is an acid and sodium hydroxide is an base. We have also a phenolphthalein, which is colorless solution, and I transfer some of the phenolphthalein solution in a test tube. Now we study what happens when an acid mixed with base. That is hydrochloric acid mixed with base, that is sodium hydroxide. So we mix an acidic solution and base solution. The salt, sodium chloride, that is new substance, is formed with water. Water is also formed, and raise the reaction solution of reaction mixture. Therefore, it is also evolved during this reaction. This reaction is called a neutralization reaction. When an acidic solution is mixed with a basic solution, both the solutions mixed in a suitable amount neutralize the effect of each other. When an acid solution and base solution are mixed in a suitable amount, both the acidic nature of acid and basic nature of base are destroyed. The resulting solution is neither acidic nor basic. In neutralization reaction, heat is always produced or evolved. The evolved heat raises the temperature of the reaction mixture. In neutralization reaction, new substance, salt and water are also formed. So we study the neutralization reaction. For this, I take some hydrochloric acid in a test tube and put a drop of phenolphthalein indicator into the acidic solution contained in a test tube, which is a hydrochloric acid. You see that in acidic solution, phenolphthalein indicators remains colorless. So I put a drop of 2 to 3 drops of phenolphthalein solution in hydrochloric acid. Now I put drop by drop basic solution, that is sodium hydroxide, to the test tube which contain hydrochloric acid and 2 to 3 drops of a solution. And see what happened. I put, you see that pink color appear and disappear in here. I put more drop by drop. You see that green color appear and disappear. I put more base sodium hydroxide in the solution contain acid. This is base added to acidic solution and destroy the chemical nature of acid present in a test tube, but in a test tube more acids are there, so one drop of sodium hydroxide destroy one drop of hydrochloric acid chemical nature of hydrochloric acid in a test tube. So drop by drop it. Now you see that all reactant mixture turned into a pink color. It means that in a test tube there is no acid, only base, a drop of base are there in a test tube, because in a basic medium phenolphthalein indicators gives a pink color. Now if I add a drop of acid into the test tube, it becomes further colorless. You see that this is again colorless. Now I repeat to add sodium hydroxide into the test tube with a dropper, drop by drop, one drop, and you see the color is slightly changed. Change colorless to pink color. This is known as neutralization reaction. Now, if we touch the test tube, we feel the one, because during the reaction between acid and base, that is neutralization reaction, heat is produced or heat is evolved, and the mixture in this test tube is now a new substance like salt, that is sodium hydroxide in this case, and water, and some heat is evolved. So this is the neutralization reaction. Thank you.